Thanks for coming. My name is Antonio Gonzalo, and in this chat, my plan is to present briefly what the Internet of Things could become. So let's start a bit with a polemic. This moment here that I'm depicting is the moment when the Internet became mainstream. That's David Letterman, and that's Bill Gates, and he's asking him, what's the Internet about? And he's saying, yeah, well, the Internet is about connecting computers. Now, that's fine. We didn't know for what, but that's all right, for connecting computers. And then we started with the thinking over there was, okay, so we are going to have access for that information because information is going to travel. So we may create services for this access. And I remember, because I'm a bit old, that there were some browsers, some internet browsers, that used to have a little wallet over there, so you can pay for the pages as you surf. That was the thinking back there. Right now, then, 9 years later, then Facebook came and told us that the internet was not about connecting computers, but connecting people. That's the actual value behind it. Of course, there is value in the access, but there's something more. And in the same way, in 2016, we got the hype of the Internet of Things. Now it's all around. In the last Mobile World Congress, it was the most common word after exit or pay here. Everything was Internet of Things, all the time. And when we ask people, what's going to be the business over here, everybody says, yeah, it's in the data. Well, it's obvious that there is value in the data. But is it really the value there? Well, it looks to me a bit like a Groundhog Day. It looks like the same story, but with a gap of 15 years. So my plan is to 3 parts, which is the presentation about, to present how things could be a little different. The first one is called, with great powers come great responsibility. That sentence that is attributed to Spiderman, or to Stan Lee, it's really from Roosevelt, but I like to believe it's from Spiderman. And it's to show how the things that are going to come. And to illustrate how the things that are going to come are, the first one is, well, it's good to speak about Teslas. Teslas are great cars. It feels like driving a video game. It's really it's super cool. And those cars are really advanced. And I'm going to show you in which way. Those are made by Elon Musk, which is a guy that actually lives in the future. He foresees things and make his own products in this way. And I'm going to tell you a little history about how these cars are advanced. About 2 years ago, a guy was riding with a Tesla through an interstate, and the things that the Teslas have is once you go over some speed, they reduce the suspension so that the air gets lower, and it gets the grab is better to the floor. So the problem that this guy has is that this was a bumpy road. So when the Tesla scratched, the bottom of the Tesla was scratched by this floor, and a rock was almost getting in. So the guy spoke to Elon. Well, he wrote an email. I don't know if it's to Elon, but I like to believe it is. And he said, okay, this problem is going on. What are you going to do about it? And from that moment, all the Teslas are shipped with a titanium layer on the bottom to prevent rocks from entering. And the second thing he did, and this is truly remarkable, is to update the suspension of all the Teslas in the world overnight. Instead of going to a garage, you change the suspension of a car remotely all around the world. That's amazing. It's really remarkable. And that's a thing that you think in advance how the problems could be. You're thinking ahead. That's how the things are going to be. But the same way that these things are really cool, at the same time, it can present a problem. Those are 2 hackers here. One is from Twitter, and the other one is from a security company. And what they did was they took a commercial Jeep. That's a Jeep Cherokee, absolutely commercial, and they hacked it. Right? For doing that, they took a guy from Wired, the actual newspaper, the magazine, and they put him aside and tell him, come on, let's drive a little bit. And they made him drive. And what happened, they did 3 things to him. The first is they hacked into the entertainment system, and they put their picture over there. That's funny. The second thing they did was they turned on the windscreens, they took the heat on, that's California, so it's not exactly cold. And they put hip-hop, top volume, and he cannot change it. Well, that's annoying, but funny anyway. But the third thing, and you can see his face, he's scared to death. What they did was they cut their transmission in the middle of the highway. That ended the fun over there. Because the thing could really become dangerous. There he is screaming at the guys, turn this thing on, this is not funny anymore. And that's all they did to him? No. They turned him to a ditch. You can actually steer the wheel remotely when the speed is not that high and actually move the car. So if these are the things to come, and the things are really cool as a Tesla's, or really dangerous as this one, as Cherokee, we need things, and we need to have trust in things. That's something that we will need in order to buy this thing and feel comfortable and reliable with the Internet of Things devices. And that's not that easy. And then, I don't know exactly why, but then it comes an unexpected player. And that's the second part, Bitcoins. And I'm sure that you've all heard of Bitcoins, because the thing is already 7 to 8 years old, which is quite a lot in software terms. Bitcoin is a decentralized currency. It's really cool stuff. It holds 6,000 million euros or dollars. Well, doesn't really matter. Already at the moment as we speak, and the history of it is really funny. Funny. It's really curious. A guy that called himself Satoshi Nakamoto, and there's some news actually that actually tell who the guy is, but we don't really know. Those news comes every 6 months. So this guy, and we don't really know who he is. He went into a forum, a cryptographic forum, which is not a very, let's say, mainstream forum, and he put a PDF over there, a PDF, 9 pages, and the last one is references, and he disappeared, and that's what he created, a virtual currency that cannot be taken down. It's really remarkable. How does it work? In order to understand a little bit, I need to present how it works. It's not gonna be very, very complex. Well, Bitcoin actually works as an email. There's no difference like that. You have 2 addresses, one sender, one receiver. You have 2 passwords, both sides, and you publish the transaction. You send the thing. The thing is that the addresses are not as easy to remember as the ones we have. Addresses are like that one over there. That's mine, by the way. So if you want to send money, that's my address, and it's based on cryptographic. That's why it's so endured and hardened to hack. And since it's a virtual currency and you can actually send transactions the same way as you would send an email, it's digital. So there comes a problem. What problem is it? The problem is called double spending. Nothing prevents me to send the same transaction to 2 people at the same time, and you need to verify that this transaction is only once. It's digital. You can't copy an email. So in order to prevent this problem, to solve this problem, that's when this property, this technological advance comes into place. And it's called the blockchain. I'm sure you've heard about the blockchain. I'm going to explain it just briefly. It's going to be really quick, and then we can keep talking about it. So how it works, when I send a Bitcoin transaction, is all the transactions are published into a pool, back in the left. And these transactions have to follow a script. There's code over there, and it's symbolized by that FX over there. And there are miners, it's called miners, that have computers, and they put their own computers to the sake of the network. And what they do is they verify that these transactions are already valid, that there's no double transaction once it happened. And you would wonder, why do they do it? They are so naive that they put their own computers for the sake of the world. No, because the network pays them. How does it work? Well, what they do is they do hashing algorithm with all the transactions, and they try to find a number. So that's the blockchain over there, and they're trying to find a 42. They are trying to solve a mathematical problem. That's hashing. It's a bit weird. It's a bit complex to talk about this right now, but believe me, it works. So what they do is they try to solve this problem. The first guy that solves the problems and says, I found it, it takes all the transactions to the blockchain, stays there, and the network rewards him with 25 Bitcoins. That before halving, it's about $7,000 or $8,000, more or less. right? That happens every 10 minutes. So all the transactions are stored in this place called the blockchain. Why is that important? Because this thing, this blockchain ledger, is not in one single place. It's all around the world. All the miners have this ledger, this book, with all the things registered. So if you want to hack the thing, you need 51%, and this is really important, 51% of the whole computing power to hack this thing. So, and it's estimated, by the way, that about all the computers in Google, all of them are less than 4% of the computational power in blockchain now. That means that you need about 10 or 15 Googles working at the same time to hack the network. And you got 10 minutes to do it. Because the moment the block goes, you got another one, and then another one. So I wouldn't say it's unhackable, but it's practically unhackable. I don't know where Chema is. So the main properties of the blockchain are basically three. It's transparent. Everyone can see all the transactions that happen in history from the very beginning, everyone. The second is resilient. You cannot take it down. And the third one is that it's immutable. What's written there, it's carved in stone. It's forever. It's not going to change. So this is blockchain. And that was the problem for my Internet of Things. And then comes the third part, which is basically the mixing the two things together and making sense on top of that. So one guy once said, okay, so we got this double spending problem, but what happened if we solved something else? What something else? And then one guy could say, okay, we can do the same thing with the chess rules. Why not? So you write in code what the chess rules are and how you move one piece to the other, and all the transactions have to follow that rules, and all the players would verify that thing. Yeah, that makes sense. Why not? You can make it. But where else can you make it? The thing is that you can make everything. Because what is a transaction? A transaction is everything around us. From opening a door, getting into a car, paying, anything is a transaction. If you want to buy a car, that's a transaction. If you want to buy a house, that's a transaction. There's transactions everywhere. So what happens if we create a platform for these codes of these different algorithms to take place? What I just depicted is a smart contract. And this thing, this platform, is already built. It's called Ethereum. That's a startup that was founded a year and 2 months ago with $18 million crowdfunded. They just opened the thing and they generated this platform. And so it's up and running. It's up and running. By the way, I love the names of it. I love the names of the release. They're called Serenities or something like that. It's really, really cool. And how does it work? Okay, just to make a brief example of how would it work with a thing like the Tesla. Imagine that the owner of a Tesla wants to lend the car. And it's read from top to the bottom, right? That's a pile. So the owner publishes a contract. Tesla implements blockchain. They publish a contract and they say, okay, I want to lend the car. There are some rules. Of course, there are some rules. The rules are you have to deposit that amount of money in case you break the thing. You have to pay me that thing. And you have to use it that way. Teslas could do all those three things. They can measure how you drive. You can pay in the block, Bitcoin or wherever other network there is, and the contract is enforced. Once it's published, you cannot take it down. So a guy can say, yeah, I agree, I buy this thing. I want to borrow that car. And then the transaction is gone. So he will borrow the car. He will use the car, and once it's gone, nobody can prevent for happening that if everything's all right, the deposit will be given back and the fees will be charged. And the beauty behind it is that what could happen, that's fine. I mean, people would say, okay, but this is a bit too complex for implementing. Just lending a car, I mean, Airbnb is going on, and Uber, and all those fellas. So why is it that complex? Why are you complicating things so much when the actual program is really, really easy? Well, what happened if Elon Musk becomes crazy and tomorrow says all cars to the ditch, or he's hacked? It's a central point of failure. And that is crucial, because through this system, and this is important, through this system, Tesla is no longer required. All the cars in the world verify that the transaction is going on. So you need no Elon Musk. He's only needed to set the ball rolling. Once it's rolling, you cannot take him back. And this is important because what happens, I don't know if anybody here used to work on Google Reader, but I was really pissed when the thing came down. And Google took the decision unilaterally. They can because it's their product. But they did, a month ago, they took one thing called Revolve and they took it down. And nobody could say a thing. And you have spent $400 on that thing and you eat it because Google says so. Well, through this way, all the Revolve users could keep the thing going on. So that's a different perspective. That's a completely shift in mind. So I'm telling that there's no need for a central point of control as long as everybody does the same thing, implements the same thing through this technology, through blockchain. Those are apps that actually are working. That idea of taking this decentralization, the thing of making things going on as they between all the people at the network is really enforcing the application. It's already happening. This is an app for forecasting. That's Dropbox. That's Uber. Over there, it's securing firmware downloads. That's supply management, crowdfunding, poker, blocks, eBays. Those things are going on, and you cannot take them down because the network enforces it. After that, so that's what I picture now. It's a DEO, a decentralized autonomous organization. It's doable through this technology. And the next slide that I have, I really love that one. It's called I called it the Volkswagen slide. And why? Because Volkswagen is the example, and I'm quoting House here. Volkswagen is the example that things can lie. Volkswagen is a good example, actually, of a code that's built and deployed, designed to lie to regulators. It doesn't improve the car. It doesn't make it faster, smoother, or no. It's just there to lie to regulators. So that means that machines can lie. Hold on. So there are ethics in machines. What? I do believe that there are ethics over there. What happens if a Tesla loses control and wants to hit, or has to hit, a grandparent and a children? What would he do? A Tesla, in that situation, would hit the child because it's a smaller object and protects the life of their people inside the car. But this is no good. That's a decision that it's ethical, and it has to be coded. So maybe we need a place transparent and mutable and resilient where to put all those complex decisions or those complex things that are important to us. And we need it not to be hacked. It has to be really, really strong. So that's how blockchain could help us. And this is maybe how the Internet of Things should be built instead of building silos, which is what we actually are doing. So that's it. There are 4 outcomes of this new technology that are possible. The first one is that everything that I have depicted here is gone. I mean, somebody hacked tomorrow the code, the blockchain code, or finds a way to hack a transaction, and this is worth nothing. The second is that the fintech, the actual finance institutions will use it. And this is very likely to happen because their mainframes are from the 70s. They still use COBOL. So I'm sure that there will be some use to it. They're actually getting together into one thing called the R3 Foundation to establish a private network, a private blockchain network to rule the financial transactions. They're seeing how they can be disintermediated, and how they want to do something about it. That's really likely to happen. The third thing is that the Internet of Things would use this technology, to enforce their properties. I am optimistic, and I think this thing could happen. And the last one, which is the most futuristic one, is that people will gather together to form organizations that actually pay everybody without need of a central head. That's utopic, but this really could happen. If any of the last two happen, we would be under the third big decentralization in the last 150 years. The first one has been capitalism. It has been the decentralization of the economy. The second one is the internet, is the decentralization of information. And the third one, this one, what we call blockchain, is the decentralization of trust. I'm closing with a quote from a writer of science fiction called William Gibson, that he invented the word cyberspace, by the way. And his quote says, "The future has already arrived. It's just not evenly distributed." Thank you.